Hello and welcome to my YouTube channel. Today, we will explore how to handle the geometry of your vector layer using QGIS. As with any standalone PyQGIS script, we begin with a standard boilerplate code. If this is your first introduction to this series, I would recommend checking out my video that goes through the boilerplate code in detail. You can find the link in the description below, or check out my PyQGIS playlist. For this video, I'll be using two layers, a point layer and a polygon layer. I will alternate between these layers to emphasize the points being made in this video. I also encourage you to apply what you learn here using the line layer, as it will enhance your understanding. With that said, let's get started. I always like to begin my code with an if and else statement that checks if my layer is valid or not. This way, it is easier to tell when my code fails. If everything is on the up and up, the name of the layer is printed to the console. If not, I print can't load layer. Before performing any spatial analysis, it's essential to check the coordinate reference system, the CRS, of your layer. PyQGIS provides a straightforward API that allows us to access the following: the official EPSG code of the layer, a human readable name of the CRS, whether the layer is geographical or projected, and lastly, whether the layer has a valid CRS. All this method gives us a full understanding of the geometry of our layer. PyQGIS also gives us the ability to change or assign a new CRS to a layer. To do that, we first need to import the QGIS Coordinate Reference System class. This class takes a valid EPSG code as a parameter. You should note, this only sets the CRS metadata. It does not transform the coordinates of your features to the new CRS. If you just use this method, it might cause problems when you are performing some analysis in the future. If you want to reproject the actual geometry data, we will need to use the QGIS Coordinate Transform class. We'll dive into that in a future video. The next thing we'll do is to get all the features of our vector layer and store it in a variable using the getFeature method. This will allow us to loop through all the features in the vector layer. Looping through all the features allows us to do a couple of things. The first thing is checking the geometry type of each feature in our layer. In GIS, and by extension QGIS, there are three main basic vector geometry types that you'll be commonly working with. So we have the points, lines, polygons for location, roads, buildings, respectively. Now, these are the basic building blocks for representing real-world features in a vector layer. PyQGIS gives us two main methods to check the geometry type of a vector layer. We have the type method, which gives us a basic information of the geometry of the layer, and we have the WKB type method, which gives us a much more detailed information on the geometry of the layer. For the type method, this method returns an integer value that corresponds to one of the three main vector geometry types: 0 for point, 1 for line, 2 for polygon. As I alluded to, this method is simple and quick, but it doesn't tell us if the geometry has more specific structures. With that, we'll need the WKB type method. So the WKB, which means well-known binary, gives us a much more detailed information and tells us exactly what kind of geometry we are dealing with. So that includes whether the geometry is a multi-point, multi-line, or multi-polygon. In order to get that particular information though, we'll need to import the QGIS WKB types class. So in the WKB type class, as you can see, it has a method called displayString. The displayString takes in one parameter, which will be the output from the WKB type method. The QGIS WKB types has another method called isMultitype method that returns true or false. telling you whether the layer or the feature is a multi-path, a multi-type or not. So we have the isEmpty method to check if the layer or the feature has no geometry. We can also use the in keyword to check if the feature has no geometry or has an unknown geometry. It's just valid method. This also tells us whether the geometry is valid or not. So what we've discussed so far relates to checking the geometry types of the feature. As we can see, we have several ways of doing this. So the next thing that we'll be doing is getting the coordinates of the feature. There are a couple of ways we can extract coordinates from each of the feature depending on what format we need the geometry type to be in. With the first option, we can simply print the feature's geometry object. This gives us a general idea, but it's not always very readable or structured. The next thing we can do is use the AskWKT method, which is the well-known text method. This gives us a much more human readable format of the geometry type and the exact coordinates. We can also get the geometry as a dictionary using the AskJSON method. This is very helpful if you want to convert the coordinates into a GeoJSON. Finally, depending on the type of geometry the feature is, we can use the following methods. AskPoint method if the feature is a point layer, AskPolyline if it's a line layer, and then AskPolygon if it's a polygon layer. There are several topics that we were not able to discuss in this video since it's getting long, such as how to create and modify geometries, how to convert not only the layer CRS as we alluded to, but also its data, among other things. I plan to dedicate a video for each and every one of these topics in the future. Therefore, I encourage you to comment, like, and subscribe if you haven't already, so you can be notified when we release a new video. Thanks for watching. See you next time. Be curious and practical. Bye.